Hello, in this video we are going to be continuing our discussion of evaluating trig integrals using strategy 2, which is to use a Pythagorean identity along with a substitution. So the first thing that we need to determine is which substitution is appropriate, because that will tell us what sort of substitution, what sort of identity we need to use to substitute in. So again, like with the last example, we're going to consider our choices. The two simplest choices would be u equaling cotangent t or u equaling cosecant t. Yes, there are other options, but these are the best to start with since they're the simplest. If u is cotangent t, then du is going to be negative cosecant squared t dt. If u is cosecant t, then du is going to be negative cosecant t cotangent t dt. So we need to think about which option is going to work. Since I wrote out u equaling cotangent t first, let's consider this option. This means that we would need a cosecant squared t to be reserved. So we could rewrite our integral as cotangent squared t, cosecant squared t, cosecant squared t dt. So this would be our reserved du here, or really more like negative du, but that part doesn't matter so much right now. Notice the rest of our functions have even powers, which means that we can use the Pythagorean identity, which means this substitution, which is u equaling cotangent of t, will work. The other substitution might work. It sort of depends on the situation. Sometimes you're actually able to use multiple substitutions for these trig integrals, but in this case we know at least u equaling cotangent of t will work. So let's go ahead and follow with that solution. So then the integral of cotangent squared t cosecant to the fourth t dt will equal the integral of cotangent squared t cosecant squared t times cosecant squared t dt. Now from here, you need to make it very clear which choice of u you're using. So you can either erase the other choice of u that you had originally written up above, or you can rewrite your u here. So u equaling the cotangent of t du is negative cosecant squared t dt. Rearranging the negative sign, we get negative du equals cosecant squared t dt. So now in our integral we have a negative du for cosecant squared t dt. The cotangent of t is equal to u, so this term becomes u squared. Cosecant squared, we first need to rewrite in terms of cotangent. So recall the identity involving cotangent and cosecant is going to be 1 plus cotangent squared t is equal to cosecant squared t. So cosecant squared t is equal to 1 plus cotangent squared t, which is then in turn equal to 1 plus u squared. So combining a few steps here then, we're going to end up with the integral of u squared times 1 plus u squared, and I'm going to pull the negative out of the integral, and then we'll have a du. Distributing our u squared, we're going to end up with the integral of u squared plus u to the fourth du, and now, like with most of the other trig integrals, we end up with just a couple simple antiderivatives. So we have negative 1/3 u cubed. I'm going to distribute the negative, so we get negative 1/5 u to the fifth plus c. And substituting back in for u, we get negative 1/3 cotangent cubed t minus 1/5 cotangent to the fifth t plus c. So our final answer is that the integral of cotangent squared t cosecant to the fourth t dt is equal to negative 1/3 cotangent cubed t minus 1/5 cotangent to the fifth t plus c.